Hi guys, welcome back to the channel. So today we are going to be looking at the today's Leetcode question, which is minimum number of arrows to burst the balloons. So we are given some spherical balloons taped on the flat, which lies in XY plane, and then we are also given the points, like points of I represents the X start and then X end, where X start will be the start of the balloon, and then X end will be the end of the balloon, and then there will not be any y coordinates for the balloon, and then we need to shoot up the arrows in such a way that the balloons will be bursted from different points along the x-axis. So we'll shoot it like upwards, and then there will be a balloons based upon x and y coordinates, and then it will burst when it is when we shoot the x in such a way that x start will be less than or equal to x and then less than or equal to x end. There is no limit on the number of arrows that can be shot. A short arrow keeps traveling up infinitely, bursting any balloons in its path. Suppose let's say we have two different balloons at the different time, so it will burst all the balloons which are in this particular line, which is to the upwards, and then we need to find the minimum number of arrows that must be shot to burst up the balloons. So we need to return the number of arrows that must burst the balloons. Suppose let's just take an example. Suppose let's say we have balloons like this, where it is it is given like this, and then let us say we have two more balloons like this. So now if you want to burst these three balloons, we can short here where there is a common between all these three elements. Now when we say we have three balloons which doesn't have any intersection, that means we can shoot up the arrow here, and then again here, and then again here. So for this we need three arrows, and then let us consider one more case where we have this and then this as here, and then one more is there is no intersection between these two. Now we'll shoot up the arrow here, and then again arrow here. So for this we need two arrows. So this will be the case whenever we have intersection, we try to use the same arrow. For that, where we have the intersection, we are going to shoot the arrow in that intersection. So let us find out how we can solve this. So let me clear and then explain what will be the what will be the intuition. So let us take this particular example. There is one balloon, and then there is one more balloon, and then let us say we have one more balloon which is like this, which will end at this particular point, and then there is one more balloon which is like this. Now, can we use only one arrow to shoot all these four balloons? No, it is not possible. Why? Because there is no intersection between all the four balloons, but there is an intersection between these three balloons. So for these three balloons, we can use only one arrow, and then for this non-intersection balloon, we should use one more. That means whenever we miss this intersection, at that particular time we need to use one more arrow. That means whenever we have this particular right, whatever the right end of the balloon is present, which will be less than the starting index of next balloon, at that particular time we need to use one more arrow instead of using the same arrow. So that will be the intuition. So we'll try to sort all the balloons based upon the starting and then ending point. So this will be sorted like this, and then again for this it is going to take this particular balloon. This will be first, and then this will be second, and then this will be third, and then this will be fourth. So for this we are going to use this particular thing. So let me consider one example, and then let me explain the solution for this. So let us say we have this particular case where we have balloons like this. So let me say that I have the balloons like 1, 2, and then 3, 4, 5. And then for other case, it is going to range between 2 and then 4. And then for other case, it is going to go from 3 to 4. And then for the other, it is going to start from 5, and then it will go till 11. So this will be the case for this. For the first balloon, it is going to range from 1 to 5, and then second balloon, it is going to range from 2 to 4, and then third balloon is going to start from 3, and then it will end at 4. Now for this particular case, let us consider the first stating this particular case. For this particular case, the rightmost element is this one. But whereas when we use this particular balloon, we should shoot the arrow in between this particular elements only, less than 4 only. If we shoot at 5, we'll miss this particular balloon. So it should be less than 4. That means we'll take the maximum right limit as 4, and then whenever we come here again, it is going to be 4 only. And then this particular 5, which is the starting of the next balloon, which is greater than this, right? So we are going to use this particular case. And then let's say I have one more as 6, and then this is going to be 7. That means at this particular time, I am going to use this particular 11 as my right, and then after coming to this particular balloon, I am going to use 7 as the rightmost element. I am going to use this particular element. So that will be the intuition. So let us go through the code. So for this particular code, we are going to sort the points based upon the x start and then x end. So it will be sorted, and then we are going to take the right, which is going to store the maximum right we can have, and then we are going to pick the current right end of the balloon. And then let's say the point starting is less than right. That means we are going to consider this particular point in this particular arrow only. So we are going to consider the minimum of right and then points of j and then 1. As I have already said that it will take the minimum of all the right elements which are being taken right now. So it will take this particular minimum and then this particular minimum and then this particular element minimum. So it will be this minimum only. So it is going to consider the minimum of all the elements which we pick right now. Now when there is a mismatch, like points of j 0 is greater than the right, that means we need to use one more number of row arrows. So that's why we are going to increase the number of arrows, and then we are going to move I to j, and then at last we are going to return the number of arrows. So for this particular case, if we come to time and space complexity, the time complexity is going to be big O of log n log n, and then space complexity is going to be big O of n. Why? Because we are not considering any extra space. Yeah, that's all for this video. Thanks for watching.